Good evening, friends. We finished chapter 10. Now it is the time for calculating the formulas which we have seen in the chapter 10. Manually, we have calculated the risk measurement like standard deviation and average, arithmetic mean, geometric mean. All these things can be calculated through the spreadsheet. First of all, we'll start with the returns. So we have calculated one stock return of getting some dividend from 100 stocks. The same question if we do here, say for example, you purchased 100 stocks paying $37, and those 100 stocks after 1 year you sold at $40.33. You got $1.85 per share as the dividend. Now, we have seen in the theory that it can be dollar return, it can be percentage return. Let us calculate the dollar return. Total dollar return, for example. So, uh, total dollar return we will calculate here. This is equal to how we will calculate the total dollar return? The number of shares, obvious, multiplied with the ending price minus the beginning price. Then you will get the capital gain. Dollar capital gain will be the number of shares multiplied by ending price minus beginning price. You will get the total dollar gain, capital gain. Now we will find the dividend gain. Dividend gain is equal to, again, now the dividends you received per stock multiplied by the number of stocks you have will give you the dividend gain. Total gain is equal to the capital gain plus the dividend gain is equal to total gain. This is the dollar return. All the returns are in dollars. Now let us calculate the percentage return. The percentage capital gain is equal to, again, so your selling price minus buying price, bracket close, divided by buying price. Similarly, the dividend return can be calculated as, dividend yield can be calculated as the dividend received divided by the price you paid in the beginning to buy the share. So you paid $37, you got 1.85 dividend. So the dividend yield will be 5%. The total return is equal to capital gain yield plus dividend yield is equal to total return. So this is the way we can calculate the returns. I hope it is clear. Now many other things are there you can calculate. Once I provide this spreadsheet to you, you can see many more calculations are being done. In the time constraint, we will go to the next section. Now let us calculate the, see, there is a very interesting function in spreadsheet, that is, the question is, for example, you will be having a question like number of years with a return greater than 12%. The large cap stocks, here is the returns of the stocks. You see, from 1926, the book has given you the return from 1926 to 2017. The returns are being provided by the author. Here is the large cap stock, long-term government bonds, US Treasury, the inflation, all these things, data is provided. Now seeing the data of large cap stocks from 1926 till 2017, if the question will be how many years the return is more than 12%, it can be a question, right? Then normally what we need to do, we have to go to the historical return, then we have to count, okay, more than 12%, 1, 2, 3, 4, 5, 6, 7, like that. And it will take a lot of time then calculating, counting the number of years when you get more than 12%. But in spreadsheet, there is an inbuilt function. Easily within a second you can do it. That is, the function is known as count if function. Just a little bit. I will zoom this. Okay. So number of years with a greater than 12% return is equal to, you can, there is a function called count if. See, you use this function, easily you can calculate this. How you can calculate? Count if the data range. Data range is historical return from here to 2000, from 1926 to 2017 is my data range. So once I do that, I will give the condition to that. Now I give the range I have provided. Now my criteria will be given. My criteria is what? My criteria is, I will write, because it is criteria, always I will put it in inverted comma, greater than or equal to 12%. Greater than or equal to 12%, 0.12. Inverted close, bracket close, enter. You see, from 1926 to 2017, you have 50 number of years, the return is more than 12%. Now you tell me, for example, how many times the return is more than 10%. For example, we can write another one. How many times the return is more than 10%? How I will do that? Again, same count if functions I will use. Count if, it's asking me the data range where from it will pick the data. The data is, for example, historical return. Or we can take, just a minute, I'll just change the criteria, it making it more interesting. Say for example, same thing I will put, okay, and instead of large cap, number of years, 12% for government bonds. Government bonds. The previous one is large cap stocks. Now it is for government bonds. How many years it gave? More than 12%. The same thing is equal to count if, asking where the government data is there. Go to the historical return, government bond is here. So from here till the end, from 1926 to 2017 is my data range, comma. Now I will provide my criteria. I have provided my range. Now I have to give the criteria. The criteria is 12% or more than 12%. That is equal to, greater than or equal to 0.12%. Bracket close, inverted close, bracket close, enter. See, 17 number of years, you have more than 12% return. Okay. Equal to 10, bracket close, enter. So this is 20 number of years the government bonds has provided, 20 number of years the government bonds have provided you more than 12%. Next is, let us put it in the red so that, okay. Now this is all about count if function. Another thing we can use here, little more sophisticated. What is that? Large cap stocks, how many years it has given you greater than 9% but less than 23%. Okay, it is greater than 9% but less than 23%. How I will do it? Again the same. I will use the countif function is equal to countif. So take this, go to the range. Range of data is my large cap stocks. And okay, so data has been provided. Now what I will say, I will give you my first criteria to the spreadsheet. What is that? First criteria will be greater than 9% is my first criteria, right? So greater than 9 means 0.09. Invented close, bracket close. So now it will search from 1936 to 2017. It will go on searching how many years it is more than 9%. From there, I have to deduct those years which has given more than 23% because that is the condition required. So I will make now minus. Again, I will put a countif function. Okay. Now again data range. Okay, up to 2017, comma. Again, I will provide my criteria. My criteria is what? It must be greater than 23%, right? So, greater than 0.23. Invented close, bracket close. So, what I have given basically, how I have created the formula? I counted the number of years more than 9%. So, it will count every percentage more than 9. From there, I deducted those years which provided me more than 23 years. So, more than 23%. Therefore, my return will be from 9%, more than 9%, up to 23%. Anything more than 23%, those years will be also deducted from the result. Then it will give you the exact number of years, 27. So, 27 years out of from 1926 to 2017, 27 years you have got a return which is more than 9% and uh, uh, equal to and less than 23%. So return ranging from 9% and 23% is 27 years. Like this, using the counting function, you can calculate number of years you can calculate. Now let us go to the average function. Arithmetic average, there are many different averages we can calculate, right? So, for example, we want to calculate the large cap, small cap, long term, small cap data is not there, large cap data is there, long term government bond is there, US Treasury returns are there. So, let us calculate the average return from the year 1926 to 2017 in this data range. What is the average return of large cap stocks? We can calculate here itself, large cap stocks, what is the average return. So how can we calculate that? This is equal to, there is a function called average. Use this function and give the data where you want to provide the data. Just select the range of data whose average you want to calculate. Bracket close. 11.92%. And once you calculate, select the range in the right and control R. All the data range you can get the average return. So here also we can calculate the average return. US company stocks average return is equal to, function is average function, use the average function, and data for large cap stocks. Bracket close, enter. And long term government bonds average is equal to bracket close. US Treasury is equal to and inflation is equal to average inflation from 1926 to 2017 is equal to this is the way we calculate the arithmetic average. All right. So any data give provided to you, you can calculate arithmetic average using the function called average. Now I think average is clear to all of you. Now let us go to the variance and standard deviation calculation. So you see variance of large cap stock returns you can calculate here. That is used, there is a function called var. Variance function is, you just use the whose variance you want to calculate. Either you have four different range of data. One is the large cap stock, US government bonds, treasury. So let us calculate the variance of large cap stocks. Go to the data. Okay, bracket close. Variance is calculated here. Standard deviation is equal to and go to the range of data. You can calculate the standard deviation. So variance also you can calculate in percentage. Variance and standard deviation you can calculate like this. Now this is the sample variance. 3.91 is the variance of the sample of stock return. Variance of the sample of large cap, the standard deviation of the sample is calculated 19.77. So sample variance and sample standard deviation is calculated now. We can calculate the population's variance and standard deviation also. How we calculate that? This is equal to, so same thing, VAR, you can use the VARP, P for population. So VARP, you can select the range of data where whose you want to calculate. You know, population means divided by n, sample means divided by n minus 1. That is the difference in statistics. So we just calculated the variance of the population. Variance of the standard deviation of the variance can also, standard deviation of the population also you can calculate here. Standard deviation of population is equal to STDEV. There is a standard deviation P for population. So here select the range which population you want to use. So here is the population whose standard deviation you can calculate. So this is the way we calculate the variance and standard deviation of the population. For the sample, we can use either STDEVS or STDEV. both way. If only you are using STDEV, that is for the sample, and you want to calculate the standard deviation of the variance, then you have to use STDEV dot P. If you want to calculate the variance of the population, then VAR dot P. Then population standard deviation and variance you can calculate. So this is the way we calculate the standard deviation and variance. Now certain very interesting things also you can calculate. What is that? Say for example, you will be given the data like average return and standard deviation is available with you. For example, here is the small cap stocks. Average return is given 16.5, standard deviation is given 31.7. Listen carefully, please. So, average return is given and standard deviation is given. Now, it is asking you uh, what is the probability of making a loss of minus 15.2 or more. So, or the profit is getting 15.2 or more loss. More loss means less value, right? So, what is the probability? Calculation of the probability of getting a loss of 15.2. In that case, we have an inbuilt function in the spreadsheet that is called the probability. It is called as the probability of less than value. Why less than? Because it is a minus. If plus, then it is a more than value. So for the less than value, normally we use inbuilt spreadsheet function called normal distribution. So normal distribution function is available now. You see, norm distribution function. So it means normal distribution. In a normal bell curve, how we can get the how much probability is there of getting a loss of 15.2. So normal distribution. So what are the value? What is the loss it is being asked to you? 15.20, comma. What is the average return? 16.5. Mean. What is the standard deviation? 31.7. And true for cumulative distribution function, false for probability mass function. So we use the cumulative distribution function. So true. 15.87% probability of getting a loss of 15.20%. Same like you have specified value is 17%, and see here it is plus. Here it is what is the probability of getting loss of 15.20. Here what is the probability of getting a profit of 17 point, because the average return is 13. What is the probability of getting 17% return? So average return is there, standard deviation is there, and there is a particular percentage is being asked to you. Again the same, you can calculate the same normal distribution function. This is equal to, you see, normal distribution is giving you the loss. For greater than value, what we will do? 1 minus normal distribution. So it's asking what is the specified profit percentage you are saying? 17. What is the mean average function you have in for the distribution? 13. What is the standard deviation for this distribution? 35.2. And again, true for cumulative distribution and false for probability mass function. So probability mass function we are not doing. So normally we use for cumulative distribution. Next, here specified percentage. What is the minimum loss an investor can expect specified percentage of the time? 20% of the time. What is the probability of getting 20% of time this average return 12.10? What is the guarantee, or what is the possibility of 20% time getting the average return? What is the probability? Again the same. So there is an inbuilt function called normal investment function. That is equal to the probabilities, exact probabilities, just give it. So then average return and the standard deviation. This is the way we can calculate for normal distribution curve. We can calculate some possibility of profit and loss. We can calculate that. Next, we can calculate the last discussion I can take because time is a constraint. Last discussion I can take for geometric mean, for example. So here is the data given. For example, the data given from 1926 to 2017, the data is provided for large cap, US long-term government bond, US Treasury, and inflation. Now, let us calculate the geometric mean. So, geometric mean is equal to, there is a function for a geometric mean inbuilt in the spreadsheet called geomean. Okay, so geomean, what are the range for whom you want to calculate the geometric mean? Here is, for example, large cap stocks. Okay, so bracket close, enter. Okay, similarly, for example, for the US long-term government bonds, geomean and long-term government bonds. Here is the long-term government bonds. And US Treasury bills. Again, geometric mean, or we can say geomean Treasury bills. So long, if the investment range is very long, geometric mean is more appropriate to calculate. And inflation, geometric mean is equal to geomean the inflation. So this is the way we calculate all the, you see, the return is added with 1. So the geometric mean is always to get the percentage of return. What you can do, geometric mean is equal to this minus 1. And so geometric mean is 10.02 for large cap, 5.12 for US government bonds, and 3.44 for US Treasury bills. Actual return, by the way, these returns are not hypothetical taken examples. These are actual returns from 1926 to 2017. Now you can add crude oil data, you can add US inflation, Saudi inflation rate, you can add so many data you can add and make the kind of arithmetic mean, geometric mean, standard deviation, variance, all these kind of calculations you can use through the uh, spreadsheet. I hope it is clear to all of you. Here the author has calculated down geometric mean. Okay, so this is the way all the some of the specific functions I have used here, and as you know, I share this with you in the uh, blackboard, and you can make practice. More and more you practice, more and more expert you will be. So I will stop the recording here. Just give me a second.